Good morning. So a fellow home educator has asked how we solve this problem, this fraction problem. But more than that, they've asked how to explain it. And explaining it is the bit that I find most people find trickier to do. So there's a couple of key parts within this question that we need to understand, a couple of key concepts. The first one is that this bit here is a mixed number and we will need to change it to an improper fraction. So you need to be able to change mixed numbers to improper fractions and vice versa. The second part of this question that is a bit of an issue is the fact that we need to know how to make a common denominator or an equivalent fraction, and we need to understand why we're doing that. Okay, so I thought I'd share that with you this morning. Okay, so first things first, we need to have a look at 5 and 1/9, okay, because this is as a mixed number at the minute, and in order to take away 2/3, we're going to need to change this to an improper fraction. So those terms don't really do it justice as exactly what's going on, so let's have a look. Okay, so here's something I've prepared earlier. Let's just zoom out a little bit. So here's some bar models, and you can see the 5 is actually how many whole ones you've got. Okay, so this is 5 whole ones. It can be bars of chocolate, it can be cake, it can be literally anything, but there's 5 of them. So 1, 2, 3, 4, 5. Those are whole ones. They are complete ones that I have already. Now, the 1/9 is the fact that I have one part in addition to the 5 whole ones, okay? So I don't have the rest of this bar. Maybe I had 6 bars of chocolate to start off with, and I've eaten 8 pieces already. Therefore leaving me with 5 bars, complete bars, and 1 piece left over. Okay, so that's what 5 and 1/9 actually is. In order to change this to an improper fraction, rather than have it as a mixture of whole ones and parts, I want to change it so that I've only got the number of parts in total. So to do this, what we need to do is, first of all, you look at your denominator, which is a 9. And the 9 tells you that there are 9 pieces in every whole. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, that's the same. You can see the lines carry through. Look, so you can see it's the same for every whole. There are 9 pieces in every whole. So what we do to change this into a mixed number is we can count up quickly using our times tables how many pieces are in 5 wholes. 5 wholes, each having 9 pieces, we're going to do 5 times 9. So if we go back to our question over here, this is what we do. We actually multiply the number of whole ones by the number of pieces in a whole, okay? So that will tell us that there's 45 pieces in 5 whole ones. Of course, we're not going to forget the fact that we have an extra piece as well, and so you just add that extra piece, okay? So 5 times 9 is 45, plus the 1 extra piece that we had down here, and that makes 46 pieces, okay? Oh, sorry, just off the camera, they couldn't see it. Right, so 46 pieces. Now, I haven't changed the size of these pieces, so they are actually still ninths, okay? So 5 and 1/9 as an improper fraction, which just means, improper fraction just means that it's more than one whole. And 46 pieces, if they're in groups of 9, you can see already the numerator is bigger than the denominator, therefore we've got more than a whole. So this is 46 ninths, okay? And we're trying to take away 2/3, all right? So let's come back over here. The second part of this is understanding why you can't just subtract 3 from 9, okay? So I've got a little bit of help from some Cuisenaire rods here, which are very useful in helping us to figure this out. So as you can see, the top bar is split into thirds, okay? There are 3 green pieces. This is a whole, and it's split into 3 pieces, okay? That's what splitting it into thirds means. You're dividing it in the whole into 3 pieces, all the same size. That bit's important. The second bar underneath is exactly the same size as the first bar, but it's split into 9 pieces. All 9 pieces are the same size, but they're different from the thirds. So if I was to add or subtract, this question is subtract, but say I wanted to add 1/3 and 2/9, what would I put as my denominator? Because at the minute, the pieces are a different size. One's in thirds and one's in ninths. And as you can see, if I add these up, bearing in mind with fractions, all the pieces have to be the same size. There is no way to decide whether I put ninths or thirds down as my denominator. So this is why we split a whole, both wholes into the same number of pieces, and that's what we call finding a common denominator. Okay, if the denominators are the same, then all the pieces are the same size, and it's easy then to determine how many pieces you've got when you've subtracted or when you've added. Okay, so the first thing we're going to do that is to find a number. Fractions is completely based on times tables because it's a repetition of the same number again and again and again. So we're going to find a number that both of these go into, so a multiple of these. Okay, now you can do that by writing out the times tables, so 3, 6, 9, 12, and if we write the 9 times table, we've got 9, 18, 27. Now we're looking for the lowest number that is in both times tables. Okay, so the smallest number that is in both is actually the 9, and you can spot that that's the same in both times tables. All right, so we're going to use 9 as the common denominator because we know we can split both wholes into ninths. Okay, so I'm just going to go ahead and put that down here so to set it up. Now, as you will see, 46 ninths is already split into ninths, so that this is the white cubes here, so they are already in ninths. So I don't actually need to do anything with those. Less work, yay. So I've got 46 ninths, okay? The Cuisinart rods don't show that, but this is just to help you understand what's going on. We need to change 2/3 into ninths, okay? Now we can do that by cutting. If you imagine it's a cake, if you've got 3 pieces of cake and you want to split it so that you've got 9 pieces of cake, you literally cut each piece of cake into more pieces, okay? But bearing in mind with fractions, all those pieces have to be the same size, which is why we use multiplication, because multiplication is a repeat of the same number, meaning that all the pieces will be the same size. So, what can I split 3 pieces into to make 9? Now, you might already be able to see that because when you use visual materials, you can see they're actually very good because you can see it. So, if I split 3 pieces into 9, okay, I'm actually going to need to split every one piece into 3. And as you can see, as I do turn these pieces over, look, you can see that if I make cuts along where those lines are, I will actually make 9 pieces all together. Okay, can you see that? All the lines line up, even the gaps, and therefore we've got 9. We've turned our 3 pieces into 9 pieces. So what do we do with the calculation? Okay, so what you're looking for, this is what I did. I took my 3 pieces and I thought to myself, how do I make 9 pieces using my times tables? So I'm going to split each piece into 3. So when you're doing this, you're going to think to yourself, how do I get from 3 to 9 using the times tables? Well, I know that 3 times 3 makes 9 pieces. And as you can see here, look, 3 groups, that was the green, and I've split each one into 3. So now I've got 3 times 3 pieces, which makes 9 pieces. Okay? Now, the numerator is a part of the same whole. Okay? The numerator was 2 pieces. So I wanted to know what 2/3 were in ninths. So I look at the 2 pieces and I can see that I've got 2 lots of 3. So can you see you do exactly the same to the numerator as you do the denominator. You work out what to multiply by comparing the 2 denominators, and then you apply that to the numerator. So 2 times 3 means I've got 6 pieces. So 2/3 is the same as 6/9. And we can see that using the Cuisenaire rods. Look, here is 9 pieces altogether. The green's split into 9 now. 2 of those pieces are 6 out of 9 pieces, aren't they? It's the same thing, all right? That's what we're trying to do. Now, once you have changed that into ninths, into a common denominator, just get rid of this bit a minute. If all the pieces are the same size, you can then go ahead and subtract. Now, with addition and subtraction of fractions, the denominator will stay the same because we're not splitting the pieces into anything else any further than we already have done. So we don't add the denominators because the denominator here shows you the size of the piece, okay? So we're going to do 46 pieces and we're going to take away 6 pieces, which leaves us with 40 pieces. So we've got 40 pieces and they're all split into groups of 9, okay? Into ninths, all right? Now, usually with a fraction, you won't leave it as an improper fraction, which is what this is. This tells you how many pieces you've got out of, and they're grouped into 9s, okay? So we're going to turn that back into a mixed number. Now remember, a mixed number gives you the same information but slightly differently. So remember this diagram? This told you that there's 46 pieces and they're grouped in 9s. Okay, that's what we started off with. Now we took away 6 pieces. So if I take away 6 pieces, okay, let's show you on this model. So we take away 1, 2, 3, 4, 5, 6 pieces, okay? So that means that what we've got left is 1, 2, 3, 4 holes and 1, 2, 3, 4 pieces. So what I've got left is 4 holes and 4 pieces out of 9. So how do you change this into this? So what we do is the opposite of what we did before. At the beginning we did 5 holes multiplied by 9 pieces gives you 45 pieces and add the extra 1. To change it back, we're going to do the reverse, which is division. So what we're doing is we're saying, how many groups of 9 can I make out of 40? So if I look at the picture, I've got 1, 2, 3, 4 holes. So how many 9s are in 40? So there's 4 9s are 36. So that gives me my 4 holes, plus an extra 4 pieces, which make up to 40. So that's 36, 37, 38, 39, 40. Okay, so then you put what you've got left out of 9. Okay, so we've got 4 pieces left out of 9. Okay, so that's how we do that calculation, and hopefully that gives you a better understanding of the why. Personally, I feel the why is really important when you're doing these things, because without that, you're still feeling a bit fuzzy and not really sure what's going on. So I hope that helped. You can ask me any more questions. My business is Teach My Child. I am a tutor and a math specialist. So if you want any more help or support, just give me a shout. Cheers for now. Bye.